Hey everyone, welcome back to the channel. This is Ahili Bhattacharya, and today we are diving into one of the coolest, most chill member of the average family, the median. In a world full of data, sometimes the mean or average can be a bit of a drama queen, getting pulled around by super high or super low values, right? But the median is that super laid back, unshakable friend who stays right in the middle, no matter what. So, whether you are a stats newbie or just need a refresher, this video is for you. Let's get into it. So, what exactly is a median? In simple terms, it's a middle value in the dataset when you line all the values in up order, from smallest to largest. It's the 50th percentile. It literally splits the data into two equal halves, okay? Now, how you find this magical middle value depends on whether your data is naked or dressed up. By that, I mean ungrouped or grouped. Let's start with the simple one, ungrouped data. This is just a raw list of numbers. There are two cases, and I have a super easy way to remember them. First, when the number of observations is odd. Your formula is here written n plus 1 by 2th observation. So you just add 1 to the total number of items n, divide by 2, and boom, that number tells you the position of the median. Let's say you have 7 numbers. 7 plus 1 by 2 is equal to 4. So the fourth number in your sorted list is the median. Easy. Case B is when the number of observations is even. This is where people sometimes get tripped up, but it's not hard. When n is even, there isn't one single middle number. There are two, so we have to make a new one. Your formula is here written, as you can see. So you find the two middle numbers and take their simple average. Let's say you have 8 numbers. N by 2 is 4 and n by 2 plus 1 is 5. So you find the fourth and the fifth number in your sorted list. Add them together and divide by 2. That's your median. It's like creating a peaceful compromise between the two middle values. Okay, now coming to the group data. Alright, level up. We will talk about group data now. This is when your data is all organized into a fancy frequency distribution table with classes like 20 to 30, 30 to 40, and so on. For this, we have a special formula that looks a bit intimidating, I know, but I promise it's just a recipe. Let's break it down step by step, okay? It is this. L plus n by 2 minus CF, CF is cumulative frequency, whole divided by F into C. What is C? What is S? S not L. Let's start. Let's decode this. L is this is the lower limit of the median class. We will find median class in a second, okay? Let's we'll hold up for a bit. So N is this is the total number of observations, just the total frequency. CF, this is the cumulative frequency of the class before the median class. It's the running total up to, but not including the median class, okay? F is the frequency of the median class itself, and C is the class width, the size of the interval. So the big question is, what is the median class? What is the median class? The median class is the class where the n by 2th observation lies. You calculate n by 2, then look at the cumulative frequency column in your table and find the first class where the cumulative frequency is greater than or equal to n by 2. That is your median class. Okay? Theory is great, but let's see it in action. Let's work through the example from my notes. This is the question, as you can see. The question is 20 to 30, the marks given and the number of students, and I have already written this cumulative frequency. So let's find our ingredients for the formula. First, n. What is the n here? N is the total frequency. The last cumulative frequency is 43. So n is 43. Find the median class. We calculate n by 2, which is the median class. How we find the median class? N by 2 is 43 by 2. Then we have 21.5. Okay. Now we look at the cumulative frequency column. Which class is the first one where the CF is more than 21.5? 20 to 33? No. 30 to 45? No, 5 not 8. Not this one too. But here you see 40 to 50 CF is 28. So this is our median class. 40 to 50 is our median class. Now identify all the values. L is the lower limit of median class, which is 40, and CF is previous cumulative frequency, which is 8, and F is frequency of median class, which is 20, and class width 50 minus 40 is 10. Okay, now you have to plug. You already have the formula. Now you calculate it, and this is your answer. Here you have it. The median marks are 46.75. See, it's just a following, it's just like following a recipe, right? Now, let's come to the advantages. Like, why use a median instead of the mean? Let's talk advantages and disadvantages. Advantages of median. First, it is rigidly defined. There is no ambiguity. Once you sort the data, the method is fixed. Everyone calculating it will get the same answer. Number two, it is easy peasy. It's super easy to understand. It's just the middle value, right? And for small data sets, it's a breeze to calculate. Number three, it's the rock. It is not affected by extreme values at all, right? This is its superpower. If you're looking at incomes, house prices, or exam scores where one billionaire or one super genius could wreck the mean, the median gives you a much better sense of the typical value. It's immune to outliers. So number 4 is open-ended friendly. Okay, you can calculate the median even if your data has open-ended classes like greater than 100 or lesser than 10, like that. The mean can't really do that. Fifth is, it is actually, wait, this example is not for 4, it is for 5. Yes, so what is 5? 5 is the qualitative king. This is a cool one actually. The median is the only average you can use for qualitative data that can be ranked. Think about things you can't measure with a number, but you can arrange, like you can say average honesty. Here you see average honesty or average intelligence. You can rank people and find the person in the middle, right? You can't do that with a mean. Like, what's your average honesty? 7.5? Nonsense. But a median works. But hey, nobody is perfect. So here comes the disadvantages. First is the even problem. With an even number of observations, it's not a single data point anymore. We have to estimate it by averaging the two middle values. So it's not as directly determined as when n is odd, right? Now, coming to the second point, not based on all data. The median cares about the middle value. It completely ignores all the other values in the dataset. The mean, on the other hand, uses every single piece of information. And number 3 is algebraically challenged. You can't play fancy algebra with the median. If you know the median of two separate groups, you can't just combine them to find the overall median for the combined group. With the mean, you totally can, right? This is a big limitation. Number 4, it can be, insensitive because it ignores extremes. Sometimes it might miss the story of what's happening at the tails of the distribution, all right? So, like to sum it up all, the median is your go to rock solid middle ground finder. It's perfect for when your data has outliers or is skewed, and it's the only choice for qualitative data. It has its limits, like not using all the data, but its strengths are absolutely massive. I hope this breakdown made the median crystal clear for you. If it did, do me a huge favor and give the video a thumbs up and subscribe for more stats made simple. Now, I've got a question for you. When would you use the median in real life? Let me know in the comments below. I love reading them. Thanks for watching, and I will see you in the next one. Stay curious. Bye.